Alright guys, so here is the second part to that lecture. Again, we're looking at the outer and inner core and how we can use S waves and P waves and their shadow zones, their corresponding shadow zones, to figure out where the outer core begins and where the inner core begins. And also, we can use the fact that the S waves don't move through the outer core to prove that the outer core is actually a liquid. So we're going to look at a little bit more detail with the core. And the first thing I want you to realize is that they're both primarily composed of iron and nickel. The outer core is about 80% iron and traces of other elements along with nickel. And the inner core is also a lot of iron and nickel, only that it's solid rather than liquid. So you can envision that outer core as just being a liquid molten iron and nickel. The core itself is about 1/3 of the Earth's total mass. So as you can see from these percentages, these fractions, the mantle and the core make up pretty much all of the Earth. The crust, once again, go back to that. It's like the skin of an apple. It's really thin compared to everything else. I want to talk a little bit more about the outer core just for a moment. And I know in the class we've talked briefly about the magnetic sphere, the magnetosphere of the Earth. It's this invisible sphere of magnetism. You can experience it pretty easily. You go out with a compass and the needle points north because of that magnetism that surrounds the Earth. Scientists have a lot of strong evidence that suggests that liquid iron in the outer core is the cause for the magnetic sphere that goes around Earth. There's a lot of beneficial pieces to that, and we're going to talk about a little bit later as well how that magnetosphere hasn't always pointed north. Sometimes there's magnetic reversals where if you were to come out during a reversal with your compass, it wouldn't point north, it'd point south. And we can use that information later on in this unit to talk about proof that we have plate tectonics, these plates on the surface of the Earth, the lithospheric plates that are moving around. Before we stop this lecture, I'm going to take a look at just a couple of other unique features of the Earth's layers. And if you look at this, and just be really brief, there's a few things you notice. That the deeper you go, the higher the temperature. The deeper you go, the higher the pressure, and the more density you have at each layer. So this kind of makes sense that you go deeper into the Earth, it gets more compact, it gets more dense, higher pressure, higher temperature, all kind of parts to the grand scheme of this here. So we're going to stop here, and when you come into class, we're going to work on a lab where we're going to look at the different layers of the Earth. Okay?